Okay, so what we're trying to do here is trying to set up, you're given the 3 origin locations, S1, S2, and S3, and then 4 destination locations, D1, D2, D3, and D4, and you're given shipping cost for each OD pair, each origin destination pair. So 35, 30, 40, 32, so I can just pick out any one of these. So for example, if you're trying to take stuff at S2 and ship it to D4, it costs you 25 cents or $25, whatever, 25 units of currency. Okay, so what I'm going to do is in Excel, I'm going to try to input these prices. So I'm going to input these prices here on my second row. So I'm going to just input them in each row: 35, 30, 40, 32, 37, 40, 42, 25, 40, 15, 20, 15, 20, 28. Okay. And I'm going to highlight these cells as my decision variable cells. Okay. I highlight these cells as my decision variable cells. And now, if these are my decision variable cell, I can specify my objective function as some product of this row with this row. Okay. So I'm going to write that sum product function here. These cells multiplied by my decision variable cells here. And this is what I'm going to try to minimize, because the objective here is to minimize the shipping cost from origins to destination. So my problem is to figure out how much stuff should I ship from 1 to 1, 1 to 2, 1 to 3, and 1 to 4, and same thing for sources 2 and 3. Okay. Now I have to specify the constraint equations. If I look carefully at these constraint equations, I have 3 of these constraints are in less than or equal to format. And then 4 of these constraints are in greater than or equal to format. And because ultimately I want to be able to write the dual problem for this problem, what I'm going to do is I'm going to specify all of these constraints in greater than or equal to format, greater than or equal to format. And to do that, I have to change the sign of first 3 inequalities right here. So I have to change these 3 of the signs. First, second, and third. These 3 signs have to be changed. And to change the sign of the inequality, I just have to multiply both sides of this equation, or this inequality rather, with -1. So basically what I have is x1 plus x2 plus x13 plus x14 is greater than 1200. So what I'm going to do is I'm going to enter these -1, -1, -1, and -1. So these are my 4 coefficient once I've applied that side -1. And then there is no coefficient for x21, x22, x23, x24. There's no coefficient for 31, 32, 33, 34 either. So all the rest of the variables will have a 0 coefficient for my first constraint. So I write down these coefficients here, and I want all of these values to be greater than -1200. Okay. So my constraint equation here will be equal to sum product of my decision variables, comma, all the constraint coefficients. Okay. Now this is just the left side of this inequality. Okay. Whatever my decision variables are going to go here, and this, what I've done in this cell, this sum product of B3, M3, B7, M7 is essentially the left-hand side of this inequality, and then right-hand of this inequality is going to be -1200. And I can set up all of these things: -1000, -800, and then 1100. The sign for these inequalities is not going to change. 400, because I'm not going to multiply these things with my -1, and then 750, and then the last one will be also 750. So this basically writes out my 7 constraints, and I just have to put the coefficients now. So if you look at the second inequality, I have coefficients of x21, x22, x23, and x24. So I'm going to have zero coefficient for these, -1, -1, -1, -1, and then to have more than 4, 4, and then I'm going to set up here some product between B3 to M3, okay, which are my decision variables. So what I'm going to do is I'm going to just put in a $sign here so that I can drag out the formula, okay. And now if you drag this formula out, what's going to happen is that this formula now becomes B3 to M3, which is a set of my decision variables multiplied by B8 and M8. And then I can write down the third one, which is going to be these coefficients. This is the third constraint equation. And then the last four are a little bit tricky, but then you have the coefficients on x11, x21, and x31, and this is +1. So x11 is right here, x21 is right here, and x31 is right here, and the rest of the coefficients are zeros. And then the last one will be x12, so that's going to be here, x22, which is going to be here, and I missed the 0 here, and then x32, which is going to be right here. Let me do one thing. Let me just set up all of these as 0. Okay, and then I could just put in for 1, 3, which is going to be here. Did I miss something? And then the last one will be the coefficient. That's going to be 1 here. Okay, so what I'm going to do is I'm going to just write down, just for reference here, this is the coefficient for x11, then x12, then x13, and then x14. This is just for reference. This does not actually play in the worksheet. So you can do x21, x22, x23, x24, x31, x32, x33, x34. So these are my 12 decision variables. I just want to make sure that I wrote down these constraints fine. 1, 1, 2, 1, and 3, 1. Oh, I did not write that one right correctly, actually. The 3, 1 should be here. There should be a 1 coefficient. Oh no, I have it here, right? So 1, 1, and 1. And actually this will be 0, and this will be 1. And then this will be 1 as well, and this will be 0. So what you can see here is that this represents coefficient of x11, x21, and x31 is 1, x11, x21, and x31 is 1, and then x12 coefficient is 1 in this equation. The second one right here, x12, x22, and x32, and then x13, x23, and x33, and then x14, x24, and x34. So now, and I already did that sum product here on this one, so you could see that all the sum product can be verified. And now I'm ready to use solver to minimize this decision cell x1. So this B4 cell is ready to be minimized subject to all these constraint equation. And remember, I've written down all these constraints that's greater than or equal to. So let me try to see if I can set up solver. If you go to data under Excel, the data tab, and this is the solver that should be visible. If you don't see that, then you go to File, Options, Add-ins, and then manage Excel add-ins and hit go. And then this solver add-in box should be checked if you don't see the solver plugin in your data tab. You hit OK. And now I'm ready to minimize this cell. So I go to solver. I'm not trying to maximize, so I'm trying to minimize the cell B4 value by changing variable cells. These are the cells that I had highlighted before. And then subject to constraints, I'm going to add those constraints. My constraints are all on these cells, and they should all be greater than or equal to. And my constraints right-hand sides are these. I hit OK. And then I make sure that I do simplex LP here and hit solve and see what I get. So as you can see, I see the 84,000, which is, so let me highlight that in a different color here, because that is my answer. So that 84,000 is the minimum shipping cost. What I want to do next is write down the dual problem for the same problem. And for the dual problem, we know that the decision variables for the primal problem. So there were 12 decision variables. So now I know that in the dual problem, I'll have 12 constraints. And I had 7 constraints in the original problem, in the primal problem. So these were my 7 constraints right here. And now 7 will be the number of decision variables. Okay. So for that, I need to transpose some matrix. So I need to transpose my decision variable matrix, and I'm going to transpose my constraint matrix and all of that. So what's going to happen is, first thing I'm going to do is I'm going to copy this matrix, and I'm going to paste it over here, but I'm going to transpose it. Okay. And my decision variable cells, I'm going to highlight them here. So let's say these 7 are going to be my decision variable cells. And I'm going to highlight it just like I did there. And you can note that there are 1, 2, 3, 4, 5, 6, 7 decision variable cells. And what's going to happen is that now I'm going to set up, for my constraints, I'm going to set up the same way like I did before, sum product of my decision variable cells with my constraint cells, a constraint coefficient cells, because that's what it becomes, and that's how I wrote it out. And then what I'm going to do is B18. I'm going to make that B18 have a $sign so that when I drag it out, it doesn't change. But I will just kind of drag these out. So these becomes my left-hand side of my constraint equations. And then right-hand side of my constraint equation, if you go through the notes and trying to convert the dual problem, will be these. I'm going to copy those over, and I'm going to paste again, but it's as a transpose. Okay, paste again and as a transpose right here. And my coefficients for my problem cell will be the right-hand side of my original constraints equation. I'm going to copy that, and I'm going to paste that as a transpose. And my objective function will be sum product of these variables multiplied by my decision variables multiplied by the coefficient of the decision variables. You hit enter, and now again you're ready to use solver to kind of implement that. And now remember, I had set up my primal problem such that all of the inequality had a greater than or equal to sign, but I'm going to have a less than or equal to sign because I'm writing my dual problem. So let's go to solver again. So data tab, I'm going to maximize this solver. I'm going to maximize this value of not B4 now. I'm going to specify a new cell by changing variable cells right here, but now my new variable cells are going to be these. And I'm going to remove these constraints. I'm going to add new ones, and my constraints are right here. And less than or equal to, because I'm trying to maximize now all of these. And you hit OK. And I'm going to do some simplex LP. That's correct. And I'm trying to maximize. You hit solve. and you get the 84,000 as your answer, which was, as you may note, that was also the answer of my primal problem, and my dual problem gives me the same answer. And with that, I'm going to stop here and we'll talk about what else might be going on here.